Okay, we switch now to the last presentation in this block here, and actually, so again, it's a motor-driven systems question. It's a motor plus pump, and Michael Koenen from KSB will present his contribution here called Energy Savings Through Pump Control and Installation. I know Michael Koenen from the work in the International Standards Committee on Energy Efficiency. He's liaison to the pump committee. And I was always impressed on how well he knows actually motor design. Now I see in his CV that he was actually working as a motor design controller. So that explains a lot. And he's currently engaged in the field of standardization and industry association for KSB. He represents them in National and International Technical Committee, and he holds a degree in electrical engineering. So I'm looking forward to his presentation called Energy Savings Through Pump Control and Installations.
Welcome to today's virtual presentation at the Motor Summit 2020, where I have the pleasure of giving you an update on real energy savings in the pump industry in Europe. Thanks to the Motor Summit team, who is doing an excellent job in this extraordinary situation of COVID-19 crisis. My name is Michael Koenen, working for KSB as a manager for standardization and association, representing KSB in different working groups as Europump, CMAP, ISO and IEC. The Green Deal may have its weaknesses in detail, but it brought us back to the core point of the eco-design approach. It is energy saving. It is not the grade of efficiency. Taking a closer look to such a plant, you will immediately realize how complex it is to build it up, to maintain it, and even more difficult to improve it in sense of reliability and energy consumption. Each part which will be exchanged or changed will affect at least a piece of equipment to its right and left. Most people talking about energy saving are talking about this little small gray arrow, trying to make the small gray arrow smaller and smaller by using component regulation, for example, IE classes for motors and drives. When I'm talking about energy saving, I'm talking about the big blue arrow. What does that mean? Later more about that. Before, let's have a closer look to the components needed to build up the extended product. What you see here are 3 components, independently produced, according to standards, and provided by possibly different manufacturers. Compliant to product-specific regulations and classified according to different assessment schemes. In opposition to the growing diversity the present development shows, these products are growing together more and more. Actually, the IEC standard 61800-9 series covers motor and frequency converter losses, and beyond that, it classifies the assembly of both as a so-called power drive system. The SEN standard EN 17038 makes another decisive step further, defining the extended product approach, combining these products mentioned above as an extended product. Combine it with a harmonized load profile to calculate an EEI value for this extended product. This procedure allows a reliable assessment of the energy consumption of such complex piece of equipment. It makes the energy consumption adjustable by using the frequency converter. It's not the old-fashioned way optimizing one single load point to the absolute optimum without looking to the left and right. It becomes obvious that the core point in the field of interaction across product boundaries is the interface management. Each expert of one product world has to translate his specific data into the universe of another product world. Therefore, it needs to fulfill some evident presumptions. You may call it the Bermuda Triangle of success, the low friction interaction of communication, understanding, and acceptance. Communication. For me as liaison officer, merging both worlds, mechanical and electrical world, I can state that communication is established and under steady improvement. We have reached a solid level and, what is beyond positive, we, the participants within this network, improve our language skills day by day. Understanding. I think the first step is done. We have detected the points of different views on the same subject. For example, electrical losses and creative efficiency. Both sides, electric and mechanic, describe the same physical phenomenon, but using different approaches. But outside of the inner circle, we cannot gain understanding when sticking to the traditional approaches. Hence, it needs common effort to convince at least the legal authorities, and then one point is still missing. It needs acceptance. The last corner of the triangle, but the most important to my mind. Even if both sides use a different wording, speaking sometimes different languages, but it needs a common perception and acceptance of the background. Even if that means to give up some ground elaborated and generated in the past, even if some work done in the past might become obsolete. We only can survive and supersede the problems and hurdle of new science when acting together. When finding solid descriptions of the interfaces between the components. Since 1994, the European pump industry, in collaboration with the European Commission, has a focus on energy efficiency aspects for their products. The different steps are on the timeline in the diagram. Since 26 years of pushing projects in the right direction, trying to bring it to the legislation, saving a bit of energy by using product-based approaches. In 2019, we saw the first draft to have the extended product approach for pumps in an upcoming pump regulation. I can give you one figure for a better understanding. We are talking about 50 terawatt-hour saving potential just by following the described extended product approach for water pumps and booster sets. To make it more visible, we are talking about the obsolescence of 5 coal-powered power plants in the European Union. The energy saving potential using business as usual component-based approaches would be far behind this figure. Let's come back to the blue arrow. Many people trying to make the gray arrow smaller and smaller by using high-efficient products. Why not managing the real demand of the application instead of raising the bar of product efficiency higher and higher, saving the energy which the application doesn't need? The application tells you exactly their needs. To make this more visible, you only have to install small sensors and put a frequency converter to the pump and connect the sensor to it. With that little solution, it is possible to save the energy which is not needed by the application. And you can save it before you convert the electrical power into mechanical power to drive the pump. The blue arrow is partly colored in red. Red is the energy which is not needed by the application. This part has to be throttled using a valve. 100% throttling is indicated in a complete red arrow. In this case, we have 100% of losses. That means it's unused mechanical energy. Let me give you an example to explain energy saving. A cooling system for a production machine using one single pump and no frequency converter. The pump produces the same flow and pressure during summer and winter. It's not controlled. The produced flow and pressure are constant over the year, but the demand by the application is more like a sinusoidal curve. You have a high demand in summer when it's hot and a low demand in winter when it's cold. By installing a frequency converter, the saving potential is about 50% in this example of the energy which is not needed by the application. Using a converter, it is possible to trim the pump by adapting the speed to the actual demand of the application. This pumping station here is another example. Here you can optimize the energy consumption. Split the application into different load points, in this case 6. Use smaller pumps instead of one big pump and turn them on to adjust the demand to the actual needs without throttling the pump. What are our opportunities? Overshort, to extend and strengthen our cooperation in the field of standardization. That means to learn from each other and not hesitating to discuss in an open manner. Let us proceed in open exchange and aligning forces. We have the same targets. We have the same challenges. Saving of energy means reduction of CO2 emissions, and that means saving resources. This will finally lead to more satisfaction of shareholders. We cannot afford splitting up forces or struggling on Caesar's part. In case you agree on the points I pleaded, the first and urgent task is to agree on the broad implementation of the extended product approach for pumps. We have to agree on application-related load profiles to enable a proper assessment of electric-driven equipment. Moreover, the very best at the end. If everybody recognizes the opportunity, everybody will gain his profit. And let's end with the words of Warren Buffett. Don't save what is left after spending. Spend what is left after saving. Thank you.
Thank you very much, Michael, for this interesting presentation. I hope to see your picture now live. Yeah, great. Hello, how are you?
Hello, can you hear me?
Yes, I can hear you. Do you hear me also?
Okay. Yeah, of course, great.
The two most common used phrases in time of Zoom and MS Teams. Can you hear me? That's okay.
That's
so
right.
Let's go. I was very impressed by this big number, 50 terawatt hour of energy savings. That's huge. And
Yeah,
I was also thinking a bit about how you can reach that. And you made this clear statement regarding the fully extended product approach, which I find interesting. I also, if I look at the KSB product portfolio, I see you got IE5 motors and you have fully integrated inverters. And I was wondering, is this the future where the pump industry goes, to a complete system approach, where only an extended product approach can give you actually performance numbers? Because I can no longer test, for example, a synchronous reluctance based on normal standards for direct online motors.
So it will end up in an extended product. So to integrate motor, a converter, and a pump to one product, and rate it to a load profile, as we do it in an extended product approach. So with one very efficient component alone, it's not possible to win the challenge and to save energy. And I think it's more important to change the view, leave the component basis, and start looking on the extended product. And in the past, we're raising the bar higher and higher, saving a percentage of a percent, and that ended up in very small changes as savings. So when we have a look at every component and the interaction together, then we can save a lot of times of that energy, as I explained it before. With pumps, it's possible to save 50 terawatt hours when you use the extended product approach and the way to make it transparent with using the extended product approach. And the solution is not to have one single, very good, efficient product. It's good to have the collaboration of these three products on a good basis.
As somebody who does testing of inverters and motors, you know, I see that I will have in the future problems testing pump systems, as I cannot actually get into the input-output of the inverter, for example, as they're completely integrated into motor and the pump. Yeah, that's interesting. I have two questions from the public. One is coming from Frank Ennenbach, and I think you covered a little bit, but he asks specifically, do you see any need for any horizontal ISO standardization to cover the extended product approach?
Yeah, that's a very good question. You have to know we already have in the different regions of the world different legal requirements on pumps. For example, in USA by the DOE, in China, in Brazil, in the European Union. And I think there is no need to have a horizontal ISO standard. These legal requirements are detailed in specific product and extended product standards. And yeah.
Okay, very clear statement
at the moment.
If we take this extended product approach a little bit further, there's the other question coming from Peter Atkin. Do you see any approach to include also the piping in this extended product approach? You know, and I think it's very difficult because you have a lot of different solutions after the pump. I mean, you have different load profiles that could account for it a little bit. But what's your opinion?
That's right. With the extended product approach, we start for clean water pumps with one load profile to classify them with an EEI level. And when you remember the second picture, which I showed, it's a typical pump installation. You see a lot of pipes and not the product. So to include the piping is quite complicated, and the energy you can save is in the whole system. So I think it's a good idea to start with the three components interacting together by a load profile, and keep an eye on that.
You mentioned that you could improve the efficiency by adding small sensors, I guess, against cavitation or against pressure requirements on the outside. And that gave me the idea, well, we no longer improve basically the systems by, you know, the mechanical or electrical or so performance, but some of it is actually software, so it's control performance. How important do you think in future will be the whole control and, let's say, Internet of Things? I mean, we're opening a complete different topic here, but also the whole approach of that we have continuous monitoring and so.
Yeah. That's a very important step in the whole picture. So let's say it in easy words, it's very important to make it transparent what the pump is doing. So in many cases, the customer don't see what the pump is really doing. It's a piece of metal, it's somewhere installed, and it does its job. So one way is to install a sensor to make transparent what the pump is doing and to make it visible. To make it visible, how many energy is the pump consuming. And at the other end, it's very important to know how big is the real demand of my application. And that is the part which I want to show with that little arrow picture in my presentation, that we have to manage the big blue arrow and delete the red part of it. So, and the red part you can make visible by using sensors. And I think it is a good idea to, let's say, not to transform the energy from electrical to mechanical power, only that it ended up in the red part of the arrow. So when we can avoid it, then it's the best way to save energy.
Mm-hmm. It seems to be a very interesting topic. We have another question from the public, which is from Fernando Nuno. What is missing in the current EU pump regulation to address the savings potential that you pointed out in your presentation? If you have a wish, what you would have tomorrow?
Yeah, at the moment we have a component-based regulation. It's the MEI regulation in the 547/2012, and we have an upcoming regulation, a revision of that, and there we can address the extended the EEI classification system up 45 kilowatt. And as we saw it yesterday from Ronald Pierce-Ravashot, that in the third quarter of 2021, we are part of the scrutiny board, and when we pass that, we're on a good way to have the extended product approach as a regulation.
Okay, thank you very much, Michael. Normally we see each other 2 or 3 times a year, but really physically on different places of the earth. So I enjoyed this talk, and I hope next year we'll have the opportunity to see each other again. Okay, thank you very much for your contribution.
Thank you. Bye-bye.
Bye-bye.